So in this problem, it says a regular hexagon is inscribed in a circle of radius 8. So we want to determine the exact area that is interior to the circle, but exterior to the hexagon. So if we draw this out, and so what we're interested in is we are interested in all of this area. Now what do we know? We know the area, we know the radius of the circle, which means we know the area, because the area of a circle is pi r squared. So 8 squared, so that means we get 64 pi. Now what we have to do is we have to figure out the area of the hexagon and subtract that away. Well, what is a hexagon? A hexagon is really just 6 equilateral triangles, which means if we can figure out the area of one of these equilateral triangles, we've got them all. So let's focus on one of them. Now we know that the radius of the circle is 8, and that's important for us because that means that these 3 sides are all 8. But if we break this down, if I draw down the altitude, that's going to break this side into 4 and 4. Now also remember that all the angles in an equilateral triangle are 60. So this is 60, this is 60. This 60-degree angle is broken in half. So this is 30 and 30. So what this does is this breaks into 2 30, 60, 90 right triangles. So going by the rule, we take the short side times radical 3, and that gives us the middle side. So now we can figure out the area of this one triangle. Area is 1/2 the base, which is 8, times the height, which is 4 square root of 3. So 1/2 times 8 is 4, times 4 square root of 3, so 16 square root of 3. Now, you have to remember that there are 6 of these, so that means we multiply this by 6 to get the area of the entire hexagon. So that is 96 square root of 3. So now, to get the area that we want, which is inside the circle but outside the hexagon, we got to take the area of the circle, which is bigger, which is 64 pi, and then from that we subtract 96 square root of 3. And there's our answer. And we're done.